All right, section 1.5, part 1. So I guess there's two parts. Secant lines and average rates of change. Oh boy. Okay, let's do it. Given this function, find the average rate of change of that function on this here interval from -3 to t. Okay, great. So this is my function, minus 2x squared plus 4x minus 3. And I would like to know about its average rate of change on the interval from 3 to t. The average rate of change, let me switch screens here. The average rate of change of a function, average rate of change of f of x is sorry, it is the slope of the secant line. Which secant line? Through the 2 points. The average rate of change has to be given. The average rate of change just makes sense. It only makes sense to ask about it on some certain interval. So these 2 points in question are the points A, f of A, and B, B, f of B. Excellent. Then the slope of this secant line is just going to be, it's f of B minus f of A over B minus A, where this is A and this is B. This is exactly how you calculate slope. It's the change in the y values divided by the change in the x values. So here we will get f of t minus f of -3 over t minus 3. So my slope is minus 2t squared plus 4t minus 3, and then minus f of -3. Okay, well, f of -3 would be minus 2 times 9 plus, or rather negative, minus 12 minus 3. Okay, all three of those numbers are negative, so it's minus 18, minus 12, minus 3, that's minus 33. Now f of minus 3 is minus 33, so here I would have to add 33 because it's minus a negative. And then that's all over t minus 3. All right, great. Minus 2t squared plus 4t, and then plus 30 over t minus 3. My objective here would be to factor this numerator and cancel with the denominator. Somehow you need to produce the cancellation between that numerator and denominator. So make sure I wrote it right. Yeah. Two ways you can proceed, I guess. You can directly try and factor that guy, or you can somehow use your long division or synthetic division. And either way, you will know how it factors. So I'll probably do it a couple different ways during this video. So I'll factor a negative 2 out of the top and be left with t squared minus 2t minus 15. And down here I still have my t minus 3. Well, let's see, how could we factor that numerator? How about into, by using a negative 5 and a positive 3. That will do it. However, I was expecting... Oh, you know what I did? Huh. This is a minus 3 right here. And I'm supposed to be taking the difference, right? So A is a minus 3. This should be B and then minus A. So this is minus negative 3. Then that makes this be positive 3 all over. And I would get positive 3 here and here. And so I have positive 3 there, and then now these cancel. And my average rate of change is a minus 2t plus 10. And that is what I will type into my answer box. Very good. Find the average rate of change of this here function, and there's our function. This time, the 2 points in question are both fixed integers instead of having this symbol t. You don't really work the problem any different, I guess, except for there's no need to factor anything, because instead you will just be able to add. The interval in question is from minus 2 to 2. So the slope of that secant line is just going to be f of 2 minus f of negative 2 all over 2 minus negative 2. And f of 2, it looks like, will be a minus 4 plus 2 plus 2. And then f of negative 2 will be a minus 4 minus 2 plus 2. And down here in the bottom would just be 4. Now this part here is 0. And the rest of it just becomes, in the numerator, a positive 4. So this is looking like 4 over 4, which is 1. The slope of that line through those 2 points is 1. All right. And we have another one like this. This time it is a cubic function. Don't expect to have to work a problem like we did in the very beginning. If it is a cubic function, that would be difficult for you to factor, because that would make it into too hard of a problem. All right, and our interval here is from -2 to 2 again. So the slope of our secant line will be f of 2 minus f of -2 all over 2 minus -2. Okay, this time f of 2 is 5 times, so the first term would be 5 times 8, that's 40, and then minus 2 squared, so that's -4, and then minus 5 times 2, so that's -10, and then -3. When I put in the -2, I get 5 times -8, that's -40, and then I put in the -2 and it gives me -4 right here. And then you put in the -2 and it says +10 and then -3. I'll make a note to leave more room next time. And then this is all over 4. Okay, well some of these numbers are going to double up and some of them are going to cancel out, right? I mean, you have 40 minus 4 minus 10 minus 3. And then when I distribute my negative, I get plus 40 plus 4 minus 10 plus 3. And it's all over 4. So the 3's for sure cancel, and the 4's cancel, and I'm just looking at 40 plus 40 minus 20. So it's 80 minus 20, that's 60. We wind up with 60 over 4, that's 15. So it's looking like my slope is 15. You nailed it, correct. Okay. Oh boy, we've got this graph here. Given the graph of the function, determine the average rate of change between -2 and 4. Okay. Well, at -2, there's -2 and there's 4. So I would imagine that we are expected to believe that right there at -2, the f of -2 is also -2 because it would go right through those crosshairs. So I'm just going to note that f of -2 is -2, and then they would have us believe that at f of 4, or that at 4, when x is 4, that f of 4 is also 4. How nifty. All right. So to find that average rate of change, you apply your definition for the slope of the secant line. Slope of the secant line is f of 4 minus f of -2 all over 4 minus -2. Now, it should just be the same numbers on top and bottom. We should just get a 1, but f of 4 is 4, and then minus f of -2, well, that is a -2, and then sure enough, you can see that the slope is 1. I wonder if we could have just gotten that just by staring at it a little bit. Yeah. Down here, you had a point that was at, so your point down here was minus 2, minus 2. The other point on that line was 4, comma 4. Right? So you had a line that went through minus 2, comma minus 2, and then that line also went through 4, comma 4. Now it only takes 2 points to define a line. And in both of these cases, the x and the y coordinate were the same. That means your function is just some transformation of the identity function. Actually, it's not even a transformation. The equation for that secant line is this. It would have to be. No other function is no other linear function is going to do that. So you could have just been clever and stared at the picture. All right, another one of these. Picture time. Our interval here is minus 5 to 1. There we go. Minus 5 to 1. So at minus 5, f of minus 5 is 6, and f of 1 is 3. So slope of that secant line would be f of 1 minus f of minus 5 over 1 minus minus 5. F of 1 is 3, and then f of minus 5 is 6. And it's over 6, so it's looking like it's a minus 1/2. I probably would not have tried to do that one by eyeballing it. Yay. Back at one of these guys. Back at one of these guys. You know, the point of a question like this is to show you that you can create this other function such that when you choose a value of t, it will tell you what the slope of the secant line is. And if we choose values of t closer and closer to the other value, which in this case is minus 2, then you will be approximating the slope of the tangent line. So here I've got the function, and we're concerned about the interval from minus 2 to t. Then f of minus 2 is looking like a minus 4 times 4, so that's a minus 16, plus 2 times a negative 2. 2 times a negative 2, that's minus 4, and then minus 3, so this is minus 23. That is a prime number. And then f of t is obvious. You just swap out the x for the t. All right. Awesome. Then let me leave room. The slope of the secant line will be f of t minus f of minus 2 all over t minus negative 2, and f of t is just a rewriting of the exact function, but with a t instead, and then minus f of negative 2. And I already learned that f of negative 2 is negative 23, so this will be negative This will be minus a negative 23. There we are. And then over t plus 2. And while I'm quite sure that that resulting numerator would be easy to factor, I do want to do it with my other strategy, because if you ever did have a function in the numerator and you couldn't, for whatever reason, factor it, like maybe it's a cubic, then this other technique will actually work for you. Alright, so there it is. I won't even factor out a 2 or anything. Okay, let me just make sure that's what I had. Sure enough. Let's give you a good opportunity to review your synthetic division. Synthetic division is just a quick and cool way to do long division. And if you don't remember long division, it's probably because you have not learned it, or you have PTSD from trauma associated with dealing with it. And if you actually have PTSD and just heard me say that, then I'm sorry, I did not mean to minimize your condition at all. But I'm sure you would agree that it is quasi-traumatic to do long division. How does this work? You put here the root that you think you can divide out. The root of that denominator is minus 2, because minus 2 plus 2 gives you 0. You list out the other coefficients, where this is the t squared coefficient, and this is the t coefficient to the 1, and this is the t0 coefficient. They must be in descending order, and you can't skip any. And then it works like this. You bring down the minus 4, and you say minus 2 times minus 4, that is 8. And 8 plus 2, that is 10. And then you repeat. Minus 2 times 10, that is a minus 20. And then 20 minus 20 is 0. Having a 0 in the last spot indicates that there's no remainder. Then these numbers are the coefficients of your the answer, right? So this division right here, this is literally a division, and this numerator divided by that denominator is exactly minus 4t plus 10. And that would work for you even if you had something in the numerator that was too challenging to factor. We could have just factored that one. It would have been no sweat, but I like to show this way. Okay, another function, and this time the interval is just a couple numbers. That's cool. So the function is minus 2x squared plus 2x plus 5. And our interval was from 3 to 5. Okie doke. So we are needing f of 5 minus f of 3 over 5 minus 3. Well, f of 5 will go in those first set of parentheses, and f of 3 will go in the next set. F of 5 is looking like minus 50 plus 10 plus 5. And f of 3 is looking like minus 18 plus 6 plus 5. Now if I distribute the negative, the 5s will cancel. Okay? Because over here is a positive 5, and then when I distribute that negative, I'll get a minus 5. So I'd be really needing to just add up minus 50 plus 10 plus 18 minus 6. And then divide it by 2. Well, minus 50 and 10, that's minus 40. And then 18 minus 6 is just 12. So I'm looking at minus 40 plus 12 over 2. Same thing as minus 20 plus 6. The answer is minus 14. It's a great exercise for your brain to do those mental calculations. The more often you do it, the more confident you get, and you'll find that you're suddenly very fast at it, and even to the point where you're not sure that you did it right and you need to go back and recheck. And then more often than not, you have done it correct if you reach that point. Here's another function, and we got a couple numbers for our interval, minus 1 to 4. So we want f of 4 minus f of minus 1 over 4 minus minus 1. We're going to divide. Then f of 4 is going to be, well, 4 times 4 is 16, times 4 is 64. So that's a minus 64 plus 5 times 16. Yikes. Well, 4 times 16 is 64. And actually, let me do it, since I'm such a mental guy. I can factor out an x. I can factor out an x squared here, and be instead looking at x squared and then minus x plus 5. And that would be easier for me to deal with. So f of 4 is going to be 16 times 5 minus 4. Cool. And then, so that's f of 4, and then minus f of negative 1. Now f of negative 1 is 6. Here's one of those cases where I got to double check. Yeah, so minus 1 squared, that's 1. It says 1 times, and then when you put the minus 1 in for x, you get positive 1. Positive 1 plus 5, that's 6. So 16 minus 6, our numerator is 10, and we have a 5 in the denominator. Answer is 2. %67 mastery. Oh boy. Now we got to look at a picture again. Given the graph below, find the rate of change from -2 to 2. Okay, well, it goes through the point -2, -2. and it goes through the point 2, minus 6. Alright, so you're looking at, you want to know the slope of the line that goes through these 2 points. I mean, it's on some level no more complicated than, you know, your run was 4, and all you need to know is the rise to get down to that other point. This point down here is this guy, and this point here is this guy, right? The x values there were minus 2 and 2, so I ran this way 4 units, and now I need to go down how many units? Well, I'd be changing from a minus 2 to a minus 6. So this is just down 4 units. Your slope is minus 1. Feel free to do the calculation, but you will just get minus 1. Same convenient interval. Run is 4. And let's see here. We'd be rising from minus 6 up to 0. So the run is 4, and we're going from minus 6 up to 0. So we rose 6 units. Slope is just rise over run. The answer is 6 over 4, better known as 3 over 2. Now hopefully I won't forget this time on this one to, I want to show you what the point of doing this kind of problem is. F of x equal to a minus 5x squared plus 3x minus 1. And the interval is from 3 to t. Here we are. Here we is. So, we know that we are looking to simplify this expression, f of t minus f of 3 over t minus 3. We know that f of t is just going to be a minus 5t squared plus 3t minus 1, and then we need to subtract away f of 3, and f of 3, it looks like, is a minus 5 times 9, so that's a minus 45. And then plus 3 times 3, so that's plus 9 minus 1. Right, so this minus 1 here is going to cancel with that minus 1 there once you distribute. T minus 3 is in the denominator. So I would be having minus 5t squared plus 3t, and then that's going to cancel with this. You distribute the negative, you're going to end up with a positive 45 minus 9. Okay, so that's just the same thing as 35 plus 1, so it's 36. And then it's over t minus 3. Now this numerator is a quadratic. You could, more than likely, factor this, right? You could stare at it long enough and figure out what it factors into. You could use some kind of technique, on and on and on. But I've got this sneaking suspicion that every single time I do this, the denominator is a factor of the numerator. Now that's a strong argument for not wasting your time trying to factor it. I think that's what it was, yeah. Over t minus 3. I mean, this is what, yeah, never mind, I won't use that notation. Over t minus 3. You could factor it. I could show you a cool technique that you've probably not seen before. But let's do this synthetic division instead, because I think this is probably the single smartest way to get it done. Because this amounts to the difference quotient. It's essentially the same thing as the difference quotient. And when you have it done like this, when you are working problems like this, the term in the denominator is always going to be a factor of the numerator. There will always be a cancellation for you to do. You're guaranteed that it's going to be a factor. I guess I would just need to prove that to myself. I haven't formally done it. I just strongly believe that it is true. I suspect it strongly. So minus 5 comes down. 3 times minus 5, 3 times minus 5, that's a minus 15. A minus 15 plus 3, that's minus 12. Okay, and then you repeat. 3 times minus 12, that's minus 36. And when you add the 36 and the minus 36, you get 0. You now know that basically that numerator, it factored like this. Minus 5t minus 12 times t minus 3. That's what the numerator is. And when that leading coefficient is different from 1, it makes it harder. I don't like to. It just makes it harder to try and factor it. 5 is prime here. It wouldn't have been that hard, but it makes it, oh boy, especially difficult if that leading coefficient is not 1 and not prime. So our answer here is just minus 5t minus 12. Super. Now I wanted to talk about what in the heck that result even means to us. Well, this is the slope of the secant line. This is the slope of the secant line on the interval from what? 3 to t. So if t was 4, then you'd have, a minus 5 times 4, that's minus 20, minus 12. So you'd have a minus 32 for your slope of the tangent line. If t started to decrease down towards 3, let me just put in 3 and cut to the chase. If t was exactly 3, then whatever this would mean, m secant, I'm putting it in quotes, what would you get? It looks like minus 15 minus 12. So that'd be a minus 27. But how can it be a secant line if it only goes through the one point? It would only go through the point 3 comma f of 3. Well, that should be the slope of the tangent line. That should be the slope of the tangent line. And if I look back here at this function real quick and make some nonsensical writing to you, it makes no sense at this point unless you've either had calculus or are visiting this video from the future. Then yeah, this right here is exactly the slope of the tangent line. So this curve is doing something like that, and right there at this point, whoops, sorry, curve is doing something like this, and right there, which is this point, that line touches the curve exactly at that point and has a slope of -27. Pretty neat. Guess it's time to write my answer. Quit yakking. What was I supposed to say? Oh, give it in terms of t. -5t minus 12. Done yet? 92%. Got to do another one now. The function here is -2x squared plus 4, and our interval is from 2 to t. Okay, f of t minus f of 2 over t minus 2. Don't let anybody tell you that this is not the difference quotient. They're wrong. Not technically, I mean, on a technicality, they're not mistaken. But with a simple replacement, this is precisely the difference quotient. What would that replacement be? But if I change my variable from t to, let's say, back to x, I would say let t equal x plus h. Yeah, that's fine. Let t equal x plus h. Let h equal 2. What would it look like? It would look like f of x plus h minus f of 2 this would just be a 2 now. F of x plus 2 minus f of 2 over what? X plus h. So x plus 2 minus 2. I'm goofing something up. Here's t minus 2. Put in the, so it says x plus 2 minus 2, so it's just x. Seems weird to me, but yeah, that's fine. If I don't say t is 2, if I just say, if we're just talking about the number x, if x is 2, then, and I don't talk to you about h, I think that's probably actually what I meant to say, then this would be x plus h. This would just be minus f of x, and then in the bottom would be x plus h minus x. And the x's add up to 0, so voila, difference quotient. Anyhow, I don't particularly I mean, I don't dislike that one, but I think this one's easier to work with and easier to understand because it's something you exactly know. It's the slope. It's nothing different than the slope. And f of t here is a minus 2 t squared plus 4, and then minus f of 2. F of 2 is going to be negative 8 plus 4, so that's minus 4. And then it's all over t minus 2. All right. So this is going to be a minus 2t squared plus 8 over t minus 2. Okay. We'll go ahead and factor it this time. So I will factor out a negative 2. Factor out a minus 2, and I'm left with t squared minus 4. Very handily is a difference of 2 squares this time. And I would challenge you to find a function and a point configured like this for which you wound up with something down here that did not result in a factorization. It's just not going to happen. We have minus 2 times the quantity t minus 2 times t plus 2 over t minus 2. These cancel. I'm going to distribute that minus 2 back in and get minus 2t minus 4. There we are. Minus 2t minus 4. There it is. Please tell me it's done by now, because how torturous it would be on you guys. Yes, we're finished. All right. So this took me a while. I kind of dragged my feet a little bit. You're not going to want to be missing any. You start missing these problems, your homework is going to take forever. It will literally assign you problems forever until you get them right in a row, over and over and over again.